So here we have some pre-algebra exam scores that have been divided into classes, and we're asked to find the upper class limit of the fourth class. So rather than say 90.5, the problem here would be then this would also be the lower limit of the fifth class, and so there'd be some ambiguity there. The upper class limit of the fourth class would be 90. That would be the highest possible score here. The lower class limit of the fifth class would be 91. That way we avoid scores that could be classified into two possible categories. Okay, on the empirical rule questions, we're working with the 68, 95, 99.7. The key question here is how many standard deviations above or below the mean are we? And in this case, our mean is 8.11, our standard deviation is 1.46, and so if we count down 1 and then 2 of these standard deviations, we'll reach 5.19. In other words, it would be a z-score of -2. And you could use the chart there, but they're asking you to use the empirical rule. So you just slice and realize that. Let me draw a quick picture. Okay, so we're sitting here at 2 standard deviations below the mean, and we want this entire area here. So we can go from the mean 2 standard deviations down would be 47.5. We get that because we know the total that's 2 standard deviations away from the mean, the total would be 95, and we're going to divide that in 2 to get 47.5. But we still also need to count the entire portion over here, this entire 50%. So the 50% plus the 47.5 would give us our 97.5. On these questions, I think the biggest thing to realize is some terminology, that the median is the same as the 50th percentile. In fact, that's a question that is asked here. What is the value of the 50th percentile? Well, they tell us that the median is 31.2, so that is the 50th percentile. They also sometimes ask about the first quartile. The first quartile and the 25th percentile are the same thing. So here, for example, we know the 12th percentile is already at 20. So the 25th percentile is certainly going to be at least as big as that, and probably more, but greater than or equal to would be a true statement. So writing out the first quartile is 25th percentile, median is 50th percentile, and third quartile would be the 75th percentile. All right, here's a commonly missed sneaky type problem. It's not really meant to be sneaky, it's meant to save you on some calculations, but it ends up getting a lot of people. So note that the sales volume and expenditures are in thousands of dollars. So the sales volume here that we're looking at is 225 since we need it in thousands of dollars. So we need to put 225 here, solve for the advertising expenditures, and then whatever we get, we need to multiply that by 1,000 to get the amount that's spent on expenditures. So do pay note to the way that they're changing the unit. So conditional probabilities can be a little bit tricky at first, just because you have to be clear on what they're asking. So here we have 19 green marbles, 20 white marbles. It says if the first marble chosen was a white marble. Now you might instantly think, okay, the chance of choosing a white marble would be 20 divided by 19 plus 20, or 20 over 39, and that's correct, but that has nothing to do with what they're asking. That part has already taken place here. This has already been chosen. What they want to know is, what's the chance that you would now choose a green marble? So you have to take this white marble you have to take this white marble out. So now we only have 19 white marbles since this has already been taken out. So now what's the chance of choosing a green? Would be 19 out of 38, or 1/2. And I guess you could do it as a fraction or a decimal here. Okay, here we have a sum rule question, and we know that there's 1,786 customers. Make use of this so you don't have to add all these up. These should all add up to 1,786, but that can save you some time. And it says, what's the probability that the customer is female and lives with her parents? So that would be right here, these 235 customers. Or is male and lives in other. So that would be male and other. So if you want to be in one of these two categories, you'd have 235 plus 140, which would give you 375, and you would divide that by the 1786. Now, what if they would ask, what's the chance of being either male and in a dorm or with parents? Then you would do male and in a dorm, or with parents here would give you two possible numbers. And I guess one other thing that could be asked is, what's the chance that they're either male or with their parents? So we have the male here, or with the parents. And here's where, in the addition rule, you're going to add these up and then add these up, the ones with parents, but you'd have to subtract out this intersection because you've double counted it. You counted those 174 customers when you counted this column, and you also counted them with this row. Again, that's not in this particular question. These are mutually exclusive, and so there is no overlap between the two things we're adding up. But if the things that were being added up overlapped, then you'd add them up separately and subtract the overlap, or the intersection. So here we have a grading scheme, and we need to find the actual numerical limits. In this case for D, so scores below the top 76 and above the bottom 6. Let me draw that real quick. Okay, so we have the bottom 6, so this would be 6% right here. And then the top 76, and so I think a common mistake would be to draw it right here so that this entire thing is 76%. But when we say top 76, we want this to actually equal 76%. And the only way for this to equal 76% is if the left side equals 100% minus that. In other words, 24%. So this entire thing here would be 24%. So this would be, maybe I can put it like this right here, is 24%. And then how do you actually get the numerical limits? Well, first you would get the z-scores. To get the z-scores, you'd look up the 0.06, and you'd also look up the 0.24 in your standard normal table or using your calculator, and you would get those two z-scores, and then you would use the mean and the standard deviation in the z-score formula in order to get the raw scores, or the variable that's designated as x in the formula. Alright, this one's a real zinger. So we have some sewing needles, and we have the diameters of the sewing needles, and we want a point estimate for the population standard deviation. So you can easily type these into a calculator or SPSS, and it'll spit out the sample standard deviation and the population standard deviation. And the temptation there would be to just grab the population standard deviation, but that's not exactly what's going on here. So we have 10 data points that are part of a population. We just have a sample. We just have a small portion of that population. And in order to estimate the population standard deviation, our best guess, our point estimate, would be the sample standard deviation. So what they really want here is the sample standard deviation, because that's the best guess of the diameters, the standard deviation of the diameters of all the sewing needles, not just these 10. So even though these words say that, we're looking for the sample standard deviation as a point estimate for the population standard deviation. Okay, here we have a question where we're really just identifying the hypotheses. One thing I want to make clear is the null hypothesis should always have an equal sign into it. That allows us to fix a distribution that then we can make mathematical calculations around. That's why we need the null hypothesis. Whether it's a mean or a proportion, we need to have that equal sign. The alternative could be less than, it could be equal than, it could be, less than, greater than, or not equal to. But the null hypothesis should always be equal to. The other commonly missed thing here, especially with proportion, is remember what we're really caring about is the population proportion, which is p, not p hat. So when we see the answer here, the null hypothesis would be the population proportion is 0.31, not the sample proportion. We know what the sample proportion is. What we want to know is what the population proportion is. And if it's no different than what the company says, it'll be 0.31. Otherwise, if it's true that over 31% do not fail, then we'd be looking at a greater than sign in the alternative. So this is a right-tailed test. So these chi-squared ones are pretty extensive questions, 10 steps. But this is the step in particular, I think, that can give the most problem. So by this point, you should have multiplied these percentages by the 260 and gotten your expected and your observed values. And then you might put them into your calculator, which at least in the TI 83 and 84, there's a chi-squared test that you can run. However, when you put this in, when you multiply some of these numbers by 260, you could get decimals. You will get decimals. And the chi-squared test, at least on the calculators that I've seen, does not allow you to put in decimals. So what do? You round it to the nearest integer is probably the best solution for this kind of problem. And that means that your chi-squared statistic might be just slightly off. And that's okay. If Hawks would count that wrong, this is the type of thing that you would call me and let me know that you missed it, and I'll go in and check, and I'll see that, yeah, you were really close. It was just the rounding thing, and I would give you full credit for that. There is another way. You could multiply all of your things, not just the ones with decimals, but everyone by 10, and then at the very end divide your chi-squared test statistic by 10, and that could give you the exact answer they're looking for. However, that would not give you the correct p-value, so I don't necessarily recommend doing that. I would just round them to the nearest integer, and if Hawks doesn't count it, when you're reviewing your test and you see that the correct answer is just a slight bit off from what you have, just let me know.